Hello, and welcome to this Sampled Tech Talk. My name is Harris Chowdhury. I'm the Product Marketing Manager here at Sampled, and today I'm joined by Dan Ryder, who is the CEO of Bridge Informatics. Thank you, Dan, for joining us today. Why don't you kick us off by telling us a little bit about yourself and Bridge Informatics?
Thank you, Harris. And thank you for having me, by the way. I am the founder and CEO of Bridge Informatics. Uh, I started out at the bench in biochemistry and molecular biology. Slowly but surely, I moved into bioinformatics and eventually started Bridge Informatics as a way to help our customers in the biotech and pharma space bridge the gap between data and insight. And what that means is we help them to translate their data into biological information.
Thanks for that, Dan. Today we're here to talk about the reproducibility crisis that's seen across many fields in science. Can you explain what this term means to our audience?
Sure. So the reproducibility crisis is essentially a challenge with consistently treating the samples the same way. Uh, and this refers to everything that's done at the wet lab bench. An example would be isolating nucleic acid and then preparing that nucleic acid and purifying it consistently. It tends to be a challenge if you're doing this in separate steps. And so that reproducibility crisis exists. It's immense, and you need to mitigate that risk of inconsistency. And a way to do that is with biobanks. Biobanks can be a great option to outsource all of that to the same team, enabled in some cases by a robotic tool, automation. And there you have consistent, reproducible treatment of those samples every single time.
Okay, so Dan, tell us about how Sampled and Bridge Informatics can work with clients to overcome this reproducibility crisis that they're seeing.
Sure. So it's very interesting, and I think most of the audience members may know this. There are significant challenges in reproducible uh, physical data, and that's different from the digital data. Once that's been extracted and sequenced, and we get that digital data, the physical data from those samples may not be reproducible for any number of reasons. One, for example, could be you have graduate students or postdocs going in and opening and closing the freezer every 3 hours. That's going to cause a fluctuation in the temperature of that freezer over time. And so, over a period of 5 years, those samples that you want to go back to may not be represented as effectively. Similarly, you have the concern of maybe a janitor. They go in, they clean at night, accidentally unplug the freezer. So the backups are there. All of those specific details are taken care of by a biobanking facility like Sampled, because you have the backups. You have double, triple backups, sometimes quadruple backups for those freezers. You don't have the graduate students and the postdocs coming in and opening those doors to get their samples. So you can trust that the integrity of those samples are very high. And when you move towards the digital sample, after the nucleic acid has been extracted from the sample, you've prepped the library, you've sequenced it, and you've gotten the data, Bridge Informatics comes in and helps by using robust, reliable analytical pipelines to analyze that data so that when you analyze that data again and again, it's the same. And especially because you're going to say, wow, this was really interesting data, but we need to go back to the other samples or maybe even the same samples. And you can do that with the biobanking facility that allows that at Sampled to go get those samples again, knowing that they're there, that there's no breach in integrity, that they can be reproducibly treated the same way to extract the nucleic acid, sequence it, and then convert that to the digital sample, and then again run that pipeline, assured that it is the exact same pipeline, uh, so that the results, when you do that comparison, it is apples to apples.
That's really interesting. Tell me, Dan, how does Bridge Informatics separate itself from other similar companies who offer these services? What is it that you're doing that can really help your clients with the reproducibility crisis?
It's a good question. Thank you, Harris. So what we do is effectively hire a unicorn. What I mean by that is to hire someone who has a significant background in bench biology, someone who, say, for example, was a molecular biologist as a graduate student, or maybe as a research assistant. They understand the importance of running an assay with the proper negative and positive controls, and in some cases have designed or modified their own assay. Then they go on to learn bioinformatics and computational biology. That's important because when they work with the bench researchers on the customer side, it's critical that they use that background not only to understand the importance of reliably finding inconsistencies, but they do so very efficiently, very quickly.
Thanks, Dan. And thank you for joining us for this sample tech talk. We hope to see you at the next one. Goodbye.
My pleasure. Thank you.